Welcome to the next video lecture on addressing modes. In this video lecture, I will be demonstrating through KEIL the different addressing modes that we spoke about in the previous video lecture. After seeing the first three video lectures, I hope that you all are familiar with how to open KEIL, open a project, create a project, add files and everything. So assuming that you are aware of the tool and how to use it, and straight away proceeding to the concept. So as usual, I'm starting with the origin H. First, let me explain you the immediate addressing mode. So in immediate addressing mode, as I told you earlier, move a comma hash 5h. So this is a very simple program. I've done it, so I'm just compiling it. It's free of errors. This evaluation mode is because this is a student edition which comes free of cost given by KEIL. But the only problem is it has full functionality except that it has a code size limit of 2K, and as far as this course is concerned and the programs what you write, this is more than sufficient for us. Don't bother about it, just simply click OK. Now when I run it step by step, all you will see is immediately A will get 05 H, which is your hexadecimal. Understood? Now let's come out of the debugging mode. Now I can represent this 5 as binary as well. So I said 0000 0101 D. Now let's see how KEIL reads it. So I'm compiling again, free of errors, going into the debugging mode. So when I step in, you see still it's the same 5H. Understood? Now let me show you register based addressing. Simple, R0 comma hash 5H, move A comma R0. It is as simple as that. Even my theoretical explanation in the previous lecture, it is sufficient, but just in case, for you to see. So when I ran the first step, you see R0 got the value 5. So move R0 comma hash 5H. So R0 got the value 5. In the next step, you should see the accumulator change from 00 to 5. You see the accumulator content change from 00 to 5, and still R0 is retaining the value 5. So as I told you before, it's a copy paste operation, not cut and paste operation. So both the places you still have the same value 05. So let me come out of the debugging mode. So now I'm going to talk about direct or absolute addressing. So this is where you need to listen a little bit carefully. So I'm saying move A comma 30H. In this is where I'm telling you the hash symbol is missing, which was present in the previous example. Now if you see, the hash symbol is missing. So this tells the assembler that this is not a data, but the address from which the data has to be fetched from. So this is the data memory address where my data is residing or being saved, from which it has to be copied and pasted in the accumulator. Okay, so now let's save it, build it, 0 errors, 0 warnings. Let me get into the debug mode. Now this is where the trick comes. Now I have told the assembler or the processor that my data resides in 30H, but have I inputted any data at 30H? No. So how do I do that? It's a simple memory dumping process, which I'm going to explain now slowly and clearly. So please pay attention. Okay. So now to dump the data in the data memory, what we need to do is go to View. Okay. Go to the View tab, expand it. Okay. Come down slowly through all the functions. You will see something called memory windows. Are you able to see that getting highlighted? Memory windows. Okay. And in memory windows, there are 4 memory windows which you can open simultaneously to view various segments of memory. But as of now, we do not need that. So I'm just opening one memory window. So just simply click that memory window. There you see the memory window appears at the bottom. Okay. Now, what is the address that I have told the processor my data resides in? 30H. So what you do is you simply type D. See, always C is for code memory. We are not working in the code memory. We have to work in the data memory. So simply say D, put a colon, type that address which you have mentioned here. If it is 20H, type 20H here. If it is 30H, type 30H here. If it is 50H, type 50H here. Just make sure you are not exceeding the memory sizes of 8051. Now that I have put 30H here, just press enter. Did you see here? The location has changed and this is my 30H. This single particular location is 30H, 31H, 32H, 33H and so on. So this is 30H. So let me put a number here as 4H. Okay. So now I have given the input data 4 at the memory location 30. So now when I run this code, this is called direct addressing. The processor will directly go to 30 memory location, data memory location 30 and fetch the data from there. So what is the data residing there? 4. So now initially the accumulator content is 0. So when I run, what you are supposed to see is the accumulator content changing to 4. Now let's run this. Do you see that? It changes to 4. Let's try this one more time. I'll reset everything. So the accumulator becomes 0. Initially I had written it as 4. Let me write it as 0A, which is equivalent to 10 in decimal. So this is hexadecimal A equivalent to 10 in decimal. So now when I run, what is the number that you should see the accumulator changing to? From 0 it should change to 0A. There you go. So it directly goes to this address and picks up the data, whatever data resides there, and then transfers it to the accumulator. Is that clear? So this is direct addressing. So then what is indirect addressing? Now the only difference between direct and indirect addressing is, in direct addressing we have given the location of the data memory. If it is one value or at the max 2 or 3 values, this is okay, not a problem. What if it is an array of 100 numbers, 500 numbers, 800 numbers? Then it becomes a problem. You cannot simply give move a, 30H, move a, 31H, move a, 32H. It's going to be a very lengthy process. So we need some kind of automation to help us travel through the array one by one. So that is where the indirect addressing comes into play, which gives us the edge. So here for indirect addressing, what I do is I use two registers, either R0 or R1. You can only use R0 or R1 and not any other register or label name. Okay. So first what do I do is move R0 comma 30, sorry, I forgot the hash symbol, hash 30H. So as far as R0 is concerned, this 30, which is the starting address location of my data, is treated as merely a number only for R0. Okay. Then what do I do is I simply say move a comma at R0. Okay. Now what happens? This particular symbol at, okay, tells the assembler that this is an indirect addressing mode where R0 has the address where my data is located. As far as this at symbol is concerned, it tells the processor that R0 has the address location in which my data is located. Okay, so as soon as the processor encounters this, it goes to the memory location pointed by R0. So R0 is like a pointer, pointed by R0 to fetch the data from. Okay, so now I told you this is an array, so there will be 30, 31H, 32H and so on. So how to increment the address location? Generally the address location is incremented by some pointer. So in this case it is R0. So simply we say INC R0. So since as far as R0 is concerned, 30H is merely a number. INC R0 is like an arithmetic operation, and the content of R0 is incremented by 1. So 30 becomes 30H in this scenario. And then what you do is, once you increment it, you have to fetch the next data. So how do you do it? Like a loop statement, you simply say yes jump back. Back is nothing but the name of the label where it has to jump. So just give the label, put a colon, and then assign it to the statement where you want to jump to. So now what happens? I have started the program in the origin. So I have moved the first starting address of my data to R0 as a number. Then using this indirect addressing directive at symbol, I am saying move a comma at R0, so that R0 now becomes like a pointer. It points to the address 30H. So the processor instructs to go to this address and fetch the data whatever resides in 30H, and then that is moved to the accumulator. Now to increment the address location, I simply have to increment the number 30 to 31. So since for R0 30 is merely a number, I say simply increment R0. So here 30 becomes 31, and I give an unconditional jump statement here, short jump, to a label called back. Where is this label back? This is where more data is going to be fetched and transferred to accumulator. Since I am not doing any arithmetic operation here, overwriting the accumulator is of no significance, because this particular lecture is only about how to work on indirect addressing. Okay, so let's save it, compile it, 0 errors, 0 warnings. So let's go into the debugging mode. Now again, even for this indirect addressing, how to dump data, as we already know, our starting location is 30H. Luckily for us, it is already there. Now I'm going to start dumping data. So it may write 1, 2, 3, 4, 5, 6, any amount of data you want, because here I have not set any counter or upper limit. Okay, so now we have about 15 values. So let me run the first step. So in the first step, R0 got 30. Okay, so in the next step, what do you expect? You are supposed to expect that the processor will go to this address location 30H, and the first data should be transferred to the accumulator. So accumulator content is 0, so it should change to what data value? Correct, the first data in the array 1. So let's see whether that happens. Yes, it does. Now when the next statement is executed, what should happen in the register side? We are incrementing R0. So the initial value is 30. So what should be the incremented value? 31. So let's see whether R0 changes to 31. There you go. R0 has become 31. Now what is the data that is there on the 31? Number 2. So when the next statement gets executed, what should happen? You should see the loop which is there. You see this arrow marks? So which is there in sjump back. Now this statement is going to be executed. When this is executed, you can see this arrow mark moving from this point to this point. Do you see that? Now only when this statement is executed, now whatever is there in location 31 will be moved to accumulator. So you should see that the accumulator changing from 01 to 02 now. There you go. Now 31 becomes 32. Again it jumps back. Now the next number should be 3. Do you see that? So 33, 4. Jump back, 5. Jump back, 6. Do you see the register value incrementing, the loop jumping back, and the accumulator content changing? So this is how indirect addressing works. Okay. Now the next thing that I'm going to show to you is about index addressing using DPTR. Is very specifically a case where if you have the data in the code along with the code itself, how to use DPTR to transfer the code into different registers or accumulators from the code memory. Okay, so this is again very similar to indirect addressing, except for that in indirect addressing the data is present in the data memory, and when using DPTR the data is present in the code memory or external memory. Since we are not bothered about external memory now, whenever I say DPTR, it indirectly means that we are going to fetch data from code memory. If there is an external memory, then I have to specify whether it is from the external memory or internal memory. Okay, but since we don't have an external memory, again I am reiterating, since we don't have an external memory, the moment I say DPTR, that means I am using the data pointer register to fetch data from code memory. Okay, the process is same whether for indirect addressing or DPTR, except for few syntactic changes. The rest all remains the same. Okay, first, as I indicated the starting address of my data, here also I have to indicate the starting address of my data. So move DPTR comma hash. I am not writing any numbers now because I haven't decided from which address my data is going to start in the code memory. So I'm just moving down here. I simply say move to accumulator. The syntax for using DPTR index based addressing is at A plus DPTR. So this is the syntax for using DPTR in index mode addressing to fetch data from code memory itself. So I am moving to accumulator the data pointed by this particular register, combination of accumulator and DPTR. Okay, as usual, increment DPTR, move A comma 00, hash 0h, just jump back, and I go here and give the label back here. Now, so again I'm telling you, origin, I have to load my initial starting address of my data into DPTR, which I have not done yet because I haven't decided where it should start from. The syntax is, again I made a mistake, it should be move C. Move is for data memory movement, and when you want to move from code memory, it is move C. Okay, if C is missing, that means it will look for data in the data memory. Since we have used DPTR to extract data from the code memory, we have to use the syntax opcode move C. I am moving the data from code memory to accumulator. Okay, so what is the address? The address pointed out by the summation of whatever the number is in accumulator plus DPTR. Is that clear? Okay. Now, as usual, like in indirect addressing, we incremented DPTR so that it can point to the next location. Then I am clearing accumulator here so that here I have decided that the address jump will be based only on the DPTR and not accumulator. As of now, learn this because bringing accumulator also into account is going to create some confusion in understanding as of now. So to get a clear understanding, as of now, I am making the jump, the address jump, only based on the DPTR content and not accumulator content. So for that, I have made accumulator content as 0, reinitialized it to 0, and then I have jumped back, and then it's going to move the next content. Now this is where I'm going to define my data in the code memory itself. So I have to give a label. Okay. So before I give the label, I have to specify the origin from where my data is going to start. So let's say 0040h. So this is the address from where my data is going to start. So since I have defined it here, I will go here and say 40h. So as far as DPTR is concerned, this 40 is merely a number. But as far as my data is concerned, that's the starting address of my data. Now please make sure that when you give this number, you can give any number here, not a problem. but please make sure that the code instructions what you have written and the data what you are going to define here does not overlap in the address. Now this is a very simple code, so it's going to take only few memory space. But if it is a lengthy code, you have to make sure that there is a proper separation between the instructions what you write and the data space what you define, if everything is going to be in the code memory. Otherwise, one will override the other and it will cause some confusion. Now that I have defined the starting address of my data, I'm going to give a label. My data. Is it necessary? It's always necessary because it's easy to identify. Next, I give the keyword db. db stands for define byte. Now after this, I can define anything. I can either define number or I can define alphabets. When I define number, I can simply type like this. When I define an alphabet, I have to put it within single quotes. Okay, let us not worry about alphabets as of now. Let's just talk about numbers. Okay, so this is where I have defined my data and my program ends here. So let's save and build it. So 0 errors, 0 warnings. Now let's go to the debugging mode. Let me close this memory window. Okay. So let's see this. So the things that you need to watch out for here are the accumulator content and the DPTR content. Okay. So now when I step in first, so this is where my code is starting. So I've defined here that DPTR will get 40H. So when I execute that statement, you can see the DPTR content changing from 00 to 0040. Okay. Now the next statement says whatever this address is referring to, pick that number. So initially what is the accumulator content? 00. So 0 plus 40 is equal to 40. So what I'm instructing here is go to the location 40 and then get the first data. So what is the first data at location 40? 1. So you should see the accumulator content changing from 0 to 1. Do you see that? Yeah. Next what I have done, I have incremented DPTR. So you should see DPTR becoming 1 here. 41 here. Do you see that? Yes. What is the next thing I have done? I have cleared the accumulator. The reason I told you is I want the memory jump to be solely based only on DPTR. So now you see accumulator content going from 01 to 00 again. Now I have given an unconditional jump statement here, s jump back. So when I execute that, it simply goes to this label back. Now what is the new content of DPTR? 41. So what is there in 41? Data 2. So you should see the accumulator content changing from 0 to 2 here. Do you see that? Great. Again incrementing DPTR to 42. Then again resetting the accumulator to 0. Jumping back, moving the content of whatever is there in 42. So what is there in 42? Data 3. So you should change the accumulator content, change from 0 to, so now it's in 0. So it should change from 0 to 3. Do you see that? Do you understand how this DPTR thing works? Okay. Now I've given you the basic idea of how to work with DPTR and indirect addressing. Now how to put into use, where to use what logic, it's all up to your creative thinking to get the job done. Okay. Thank you.